Today, on how it's made. Anatomical models. Jukeboxes. Tortilla chips. And spark plugs. In the 18th century, anatomical models became widely used for educational purposes. However, there were unique pieces carved in wax, which made them expensive and fragile. Today, they're made of plastic-based resin and are found in medical schools, doctors' offices, even art schools. This model of a human torso has 20 removable parts. The front, sides, and back all provide different views of the body's inner and outer structure. Workers cast each part of the model using a plastic-based polymer resin. They pour the resin into nickel molds of the different parts, like this skull cap mold or this heart mold. Then they join the two molds that make up each part and clamp them shut. The molds go into a gas oven set to 225 degrees Celsius. As the heat penetrates the molds, the resin evenly coats the entire inner surface. After about 10 to 12 minutes, they come out piping hot. Workers spray them with water to cool them down before they unclamp the mold and release the warm casting. Here are some shoulder muscles, fresh from their mold. The cross-section of a heart. An arm. And a leg that workers set to cool into shape on a form made of heat-resistant gypsum. Using a needle, a worker punctures the resin to release trapped air so the part doesn't shatter. Then he drills small holes for the pins that will hold the parts together. Each part is hand-painted to single out key features. An artist carefully paints the veins in blue on this leg, then uses yellow for the nerve endings and red for the arteries. Even the toenails get some color. Before they can assemble the model, workers must first insert metal pins into each part. They help attach the parts to one another. Now the artist can finish painting in the arteries on the shoulder muscle. The gray areas indicate the ligaments. Next, she turns her attention to the head, painting in the eyes first to give the figure some life. It's all in the details. This final touch really makes the eyes come alive. The parts go into a warm oven for about 15 minutes to soften the plastic. This makes them easier to assemble. Here, a worker lowers the model's head onto a metal pin set in the torso. She puts the brain inside the model's skull and covers it with the skull cap. Next, she adds muscles to an arm, guiding the pin into a hole on the adjoining part. She adds the bicep, a muscle that helps flex the hand. And finally, the deltoid, the muscle that lifts the arm at the shoulder joint. She tapes up the arm to keep all the parts together as she attaches it to the torso. Nickel-plated hooks and fasteners hold the removable parts in place on the assembled model. This life-size muscular figure model measures in at 1 meter 38 centimeters. It has 45 separate parts, all anatomically correct. The human body, truly an extraordinary structure. The jukebox actually started out as a memo recording device for executives. That phonograph recorder was invented by Thomas Edison back in the 19th century. It evolved into a coin-operated music machine, because music is a lot more fun to dance to than the boss's orders. Take a memo. Put a coin in the slot, and people will dance to your tune. Records replaced the phonographic cylinder early in the 20th century. Amplifiers were added in the 1930s and gave the big box a big sound. In the 1980s, compact discs came along, putting a different spin on the jukebox. With those smaller discs, manufacturers could pack a lot more music into a machine. Now, compact disc technology is becoming outdated, and the latest jukeboxes contain computers that download songs from the internet. To make a modern jukebox, they start with the door. They sandwich a red panel with swirled designs on it between layers of plastic. The assembler aligns them, then screws them together. He snaps the jukebox name into a snazzy piece of plastic, then fits it into one of the cutouts in front of the door. Next, he installs aluminum framework around the door. He supports it at the corners with metal brackets. He screws a little metal wheel on the latch so the door will open and close smoothly. He mounts the touch screen in the big cutout on the door. He strings wiring for lighting around the perimeter of the door and fastens 2 long panels equipped with LED lights to the back. He plugs in the lights for a test, and it proves this door is flashy enough for the entertainment biz. He runs plastic trim along the perimeter of the door and screws a long metal hinge to one side of it. This jukebox door is now complete, and the rest is an inside job. The assembler installs an exhaust fan in the jukebox cabinet. He screws an audio amplifier to the back wall. The wireless router that allows the jukebox to connect to the internet goes in next. He mounts the power supply system to the side wall of the cabinet. He tucks the computer into a lower corner of the box. The power transformer for the amplifier goes on the back wall. He installs an audio control system just below the transformer. He connects the amplifier to the audio control system, and then he wires the computer to the router. He hooks up a communication system that passes information between all the devices in the jukebox. And he installs a transformer for the speaker system. Now the jukebox is ready for the showpiece, that light-studded door with the touch screen. He screws the door's long hinge to the cabinet. He inspects his installation job and determines no adjustments are needed. So he fastens the bill box to the back of the door and installs the computer hard drive in the cabinet. And finally, the money test. He feeds the jukebox some cash and makes musical selections to check its function. At the jukebox factory, when the job is done, it really is party time. On their own, dipped in salsa or guacamole, or topped with chili and melted cheese, tortilla chips are the quintessential Mexican snack, even though they're actually an American invention. In the late 1940s, a Los Angeles tortilla factory began cutting and frying leftover tortillas, selling the first tortilla chips. When the chips are down, they usually go fast. Tortilla chips start out as raw yellow corn. The supplier cleans the kernels and dries them to a moisture content of 14%, then ships them to the chip factory. There, the corn goes into large stainless steel cooking kettles filled with almost boiling water. Workers then add lime, an ingredient that does many things. It's antibacterial, it gives the corn a parched flavor, it helps loosen the hull, the kernel's shell, so it will come off later on, and lets moisture penetrate the kernel. Each cook kettle contains about 300 kilograms of corn and 90 kilos of water and lime combined. Next stop is a soak tank. The cooked corn sits there for 12 hours to further absorb water. Once the moisture content hits 45% and the hulls are soft and loose, a pumping system moves the corn to the washer. This machine strains the water so that what's left is just soft, hydrated corn. The next stop is the tumbler, a rotating drum with perforated walls. Water jets blow off the loose hulls. The corn travels on a conveyor from the tumbler to the mill. An auger feeds the corn into a stone grinder. It literally pulverizes the corn kernels between two stones, producing a soft corn dough called masa. The masa exits the mill through a narrow nozzle that shapes the dough into a thin sheet. The sheet then runs through rollers that have triangular dies on their surface. The triangles move into an oven heated to 340 degrees Celsius. They spend just 16 seconds inside, but that's enough time to dry the dough to the point where it won't break apart when handled. The heat also traps tiny pockets of moisture in the dough, creating little blisters. This gives the tortilla chips their trademark bumpy texture. From the oven, a conveyor belt transports the triangles to the fryer. The corn oil is 182 degrees Celsius. They take just 55 seconds to fry into chips. A mesh conveyor belt then lifts them out. As they leave, the excess oil drains back into the fryer. At the next stop, augers feed nacho flavor seasoning into a tumbler. The seasoning's main ingredients are powdered cheddar, Parmesan, and Romano cheeses, and spices. Nozzles spray the chips with corn oil to make the surface adhesive. Then the seasoning tumbles on and sticks. After exiting the tumbler, the chips travel to the packaging department. Chutes route them to different packaging machines. The packaging equipment represents technical choreography at its finest. Each machine has 14 bucket-shaped scales. When there's enough for one package, a trapdoor opens. The chips drop, just as a forming device shapes a piece of foil and plastic film into a bag. The chips land in the bag, then a heat sealer immediately closes the top and cuts it free, while simultaneously sealing the bottom of the next bag. From bucket to bag to bowl. It takes a spark to get your motor running. The spark plug was invented in the 19th century to fire the internal combustion engine. There are usually several in an engine, and they fit into the cylinder head. When the plugs are all working, it means your trip will have a good start. The spark plug produces what looks like a mini lightning bolt to ignite the gas that runs your car. To make spark plugs, they blend alumina-ceramic powder and other ingredients with water. After a thorough mixing, the milky-looking brew drains into a big dryer, which converts it back to powder. The powder funnels into a mold. It closes to press the powder into the shape of spark plug insulators, and a binding ingredient in the mix helps them keep their shape. An automated system loads them onto mandrels that spin the ceramic insulators against a grinding wheel. It grinds them into a more graduated shape and does a very precise job. These ceramic shapes are quite fragile, and they'll need to be baked in order to harden. But first, a tester double-checks the measurements with a laser tool. Then they bake in this very hot kiln until they're extremely hard. This takes up to 24 hours. While the insulators are in the kiln, tools ram steel through shaped cavities called dies. They're essentially punching out shells that will be the spark plug casings. Other tools bore into the upper part of the shells to give them a hexagonal profile. This will later enable mechanics to wrench them into a vehicle's engine block. More tooling contours the spark plug shells, and the result is quite a transformation. A conveyor now shuttles the spark plug shells forward as nickel alloy wire unwinds overhead. An automated welder fuses the wire to the shells. This wire will serve as the spark plug's ground electrode, and it will be bent towards a firing electrode later. The space between them will contain the spark. Ridged rollers carve threads in the steel shells so they can be screwed into the engine block. The shell then gets a protective, silvery finish. The ceramic insulators are now out of the kiln, and it's time to roll on the insignia. The insulators then brush by a rubber wheel that coats them with a glaze as a protective finish. They install center electrodes in the insulators, and powder funnels into them to fill the space around the electrodes. The powder is a mix of glass and metal. Automated prongs compress it in the insulators. Grippers then insert the terminal studs into the insulator. The stud will act as the electrical connection to the center electrode. The insulators now go into an oven. The black powder melts around the studs and center electrodes to seal them inside the insulator cavity. Nozzles squirt oil onto the metal shells to lubricate them. The insulators funnel into the grip of robots, which install them into the shells. They slide in easily because of the lubrication job. Tools called shrinking punches apply an electrical current to each shell to fit it tightly to the insulator. A robot positions the assembly right side up with the side electrode protruding, then bends that side electrode towards the center one. The robot then collects the spark plugs and sends them down the line. It's time for an inspection. She looks for imperfections in the glaze, the inscription, and the nickel plating. She measures the space between the two electrodes before sending them over to the packaging department. And now, these spark plugs are ready to keep your engine firing on all cylinders.